Yep.
Yes, yes. Okay, so starting from the question number 11, that is our first question. So in question, the value of electric current is mentioned. The current in the transmission line used to supply electrical power to a village is 65 ampere. So this is the value of electric current, and the power is transmitted at a voltage of
That's the words.
23,000 volts.
Yes.
So yes, this is volt V. Now in first part, calculate the power supplied to the village. So first part is quite simple.
So we have to multiply because P equals VI.
Yes, so you just need to multiply P is equals to VI. So P is equals to V60, sorry, 23,000 multiply.
Multiply by C5,
Yes.
which is 1495 and then 1000.
Okay, 1495 and 1000,
Yes.
right?
Yes.
Okay, so you also write in simple notation, or if you want, so you may also write the answer in scientific notation, right?
1.495 multiplied by 10 over 6.
Yes, or we may just use a round off value like 1.5 exponent, like this 1.5, because we write 1.49 and you know that
Yes. Yes.
49 will round off, so it will be 1.5 exponent 6, right?
6. Yeah.
Uh, the SI unit of power.
The power watts.
Yes, so what is the SI unit of power? So we use W. Okay,
Yep.
okay, so your answer is 1.5 exponent 6 watt.
Yes.
Or one more thing, let's suppose if you just replace this 10 to the power 6 with the name of the prefix, so you may also write this answer as 1.5 megawatt, right? Because you know that mega gives you the same value of 10 to the power positive 6, right?
So if you add
Minus
any of
6.
the answer, it'll still be correct.
Yes, because there are multiple choice to write the answer, because they don't mention the SI unit. So it's up to you. Either you may write the answer in scientific notation. It is better to write in scientific or with the prefix, right? So try to round off the value and write in uh, scientific notation or with the prefix number, right? And we
Uh,
also we discussed that we need to round off value to two or three significant figure. So 1.5 in marking scheme, you also find the same 1.5 because they used to round off till two scientific notation figures, right?
yes.
Okay, next part, the transmission line has a resistance. So now we are having a resistance of 3 ohm. Calculate the potential difference across a 3 ohm resistor that carries a current of 65 ampere. So we need to calculate the potential difference. It means V is unknown. We need to find out
Yes.
the value of V. Value of resistance is 3 ohms and the value of electric current is 65 ampere. So which formula will help you to find out the value of V?
Um, the potential different one. The
Ohm's law?
oh yeah, ohms down.
Yes, Ohm's law, V is equals to IR, right?
Yes. Yes.
We know that we apply Ohm's law on fixed resistor when the value of resistance remains same. So here the value of resistor is fixed 3 ohms. So we are going to use the same formula for Ohm's law. V is equals to IR.
VH
Yes. So 3 by 65, 195.
195. Yes. 195.
So 195 is the final answer. And okay, so next question, part of this question, the thermal energy produced in 1 second. So time is mentioned over here, 1 second. And again, the resistor remains same, 3 ohms that carries a current of 65 ampere. Again, the value of current remains same. So you need to
Yes.
find out the thermal heat or thermal energy that is produced in 1 second when passing a current of 65 ampere from 3 ohm resistor. So if we talk about the quantities, so quantities are, again, we have value of electric current, we are having a value of resistance, value of time is also given, and we
Yes.
need to find out the thermal energy. So focus on this word. Thermal energy means you need to actually calculate the energy, because heat energy is also a form of energy, right? Electrical
Yes.
energy is
Yes.
also a form of energy. So which formula help us to find out the value of E?
The E equals
Yes,
times multiplied by R.
yes, because if we consider the basic formula of electrical energy, so we know that E is equals to VIT, right?
Yes.
But the problem is we are having a value of R, T, and I. So T and I is okay, but we need
R.
to replace, yes, we need to use the value of R over here. So what we need to do?
So we had to find the V. So we'll
Yes,
do the V equals IR.
but you know that you already calculated the V from previous part, right? Because you need to
Yes.
use
Yes.
the same formula again. So we use the value from the previous part, because
Yes.
you can see that question is of only 1 mark. So it means that it is not much very lengthy one, because
Also
you can,
195 multiplied by 1 second and
yes.
3.
So 195 multiplied by I, 65 multiplied by 1. So your
It
answer is
is 12675.
12675, or you may just again round it off 1.3 into 10
Yes.
to the power positive 3, sorry 4,
For
and SI unit for energy, joules,
it's
right?
joules. Joules. Yes.
Yes. Next part is state one advantage of transmitting electrical power at high voltage.
So like if the high there's high voltage, that's means there'll be more energy.
Okay. Okay. So answer is very simple. Because we need to write the advantage. So to write the advantage, we just simply use the concept that transmitting electrical power at high voltage. So at high voltage, and you can say that this is a natural process whenever we are going to supply electrical power at high voltage. So the value of current will be low, value of electric current will be less. Second thing, and you know that if the value of electric current is very much low, so resistance is also very much low, right?
Yes.
Because
Yes.
resistance always act in the
I
opposite.
will. How will the value of I will be less like that?
Yes, if you need to find out this concept, so we know that if we use the concept of V is equals to IR, and if we just shift it over here, V over I equals to R. So since we know that R is inversely proportional to I and directly proportional to the V, but when we are going to transmitting electrical power, so you need to use the formula of electrical power. P is equals to V square over R,
Ah,
right? So now you can
yes.
see that the power is inversely to the resistance but directly to the voltage. So it means that if we are increasing the voltage, so your resistance or the value of resistance is low, and when the value of resistance is low, so it means that your value of electric current will also be low, right? Because if you have a
Yes.
high resistance, so it means that value of electric current is also high, because it is just like moving in forward direction and friction is acting in backward direction. So action reaction concept.
Okay.
So that's why the value of electric current will be low, and the
Even if you write this, will be okay. Because 1 mark.
yes. So resistance, or you may just simply write that resistance will be lowered at this stage. So that will decrease power loss. Right? If we know that from power station we need to transfer that charges or electricity to the village or to the houses. So it's our main purpose to make a high efficiency to transfer electricity from the main power plant to the village or to the grid station of our city, right? So that's why we use high voltage. So that will
Oh,
decrease the power loss. And this question is mostly asked in many papers. You will find this question for 1 mark, 2 mark, even for 3 mark, because this topic is also included in our next chapter, practical electricity. So this topic we are also going to discuss again in our next chapter, right?
oh,
Okay, we will discuss this second part with the second chapter, that is practical electricity, because this concept is related to practical electricity, right? Because this is the same concept that they ask in the first part, but now they are asking with the values. So for this, we need to study whole transmission process, that how electricity transfers from the plant to the village or to the houses, right? So just
yes.
leave this part. We will discuss it in the next chapter.
Oh,
Okay, this is a very simple circuit. It is not much difficult for you to identify. In question number 12, there is a circuit diagram, right? And in circuit diagram, there is a main supply of 230 AC main supply. And you know the difference between AC and DC. In AC, you know that current will move in both direction. In DC, current will
yes,
only move in one direction, right? So usually
yes.
battery gives you the concept of uh,
AC
DC, and the
and
main
AC.
supply of our houses give our concept of AC.
AC.
So in this diagram, you can see that if we start moving from this side, so there is a gap in the circuit, right? So it means this S1 gives you the concept of switch, right?
Yes,
Like the switches we used in our homes to turn on and turn off the component or any device. And there is an other switch S2 over here. So there are two switches, so we can operate circuit according to our choice. And there is a heater connected in the circuit. There is a fan motor connected in the circuit. So it means that we can on and off both thing at the same time, or uh,
it's
alternatively.
not satisfying. Yes,
Yes. So now the question is, the oven contains 3500 electric heater. Oven means the heater. They are talking about the heater, because oven works like the heater. So there is a power of value of power given over here, and electric fan operated by 200 watt. So there are two values of power, and there are two switches S1 and S2. When switches S1 and S2 are open, both the heater and fan motor are off, as shown in figure 12.2. So the meaning of this statement, when the S1 and S2 are open. So S1 and S2 are open means they are disconnected, right? So when they are
yes,
talking about the word open, so open means your button is simply off. And when they use the term close means your button is actually right. Like we
yes,
just connect this, so you know, can see that now this path is closed. So that is the concept of open and closed. So for the diagram, they just mark up the values in the table. S1 open, S2 open, heater is off, fan motor is off, right?
yes,
Now for the next part, we need to fill the table. And for that, they just give you a reference point. In second option, heater is off, but fan motor is on, right? So it means that we need to turn on fan motor only without opening the heater, right? So which switch we need to connect, or we can say that which switches need to be open or which switch needs to be closed. Let's suppose,
for like if so like if the first one is open, then the fan will close.
okay, so we know that if we turn on the switch one, so then current will start moving in the circuit. Otherwise, no current will flow through
Yes, yes,
any device, right? Because S1 is the main. So we
yes,
just need to close S1. So current will easily pass through this one, this direction through the fan motor, right?
yes, yes,
So there is a gap in S2, so that's why heater will not turn on because there is incomplete circuit for heater. So it means that for S1, we need to close S1 and S2
And
remains open, right?
yes, yes.
So the blue one is for this part, the second part. Now the third one, both are open.
So both we have to close.
Yes, so now we need to close both
Close
the ends.
both.
Yes, so now current will easily flow in both direction through both components. Okay, explain how the circuit represented by figure 12.1 ensures that the heater cannot be switched on when the fan motor is off. So now they are asking the same thing that we are talking about it with the circuit. So they are
Yeah.
talking about ensures that the heater cannot be switched on. Heater cannot switched on when fan motor is off. So there will be another possibility. Let's suppose if I consider another possibility, this will be on and this will be off. It means that we are
Yes,
talking
yes.
about that heater will on and fan will off. So this fourth option is not possible, right?
Yes, yes, because for the current to move all around the circuit, the S1 needs to be closed.
Yes. So your current needs to flow through S1. So S1 is our important component or
Yes,
important
yes,
switch that actually connects whole circuit. So we just need to write that statement over here because current starts to flow from switch and is connected series. Concept of series and parallel combination, right? We discussed in the concept of resistance, series combination and parallel combination. We discussed that or not? Yes.
yes,
So you know the concept of series and parallel combination. So you know that when something is connected in series, so if you disconnect that component, so all circuit is going to be turned off, right? Because series means
yes,
one by one, right? So if something is
yes,
missing in the series, so all series will collapse or there will be no movement in the charges in the circuit. With AC supply, so because current starts to flow from S1, it is connected in series with the AC supply. So it is not possible.
so heater cannot be switched on if fan is on.
Yes. Rephrase your answer by your own. I'm just writing for reference. You may take any statement for your answer. But the important thing is that we need to mention the series combination because series combination has a scientific value and scientific explanation itself. So try to use these key terms that we studied in our chapter, right?
Okay.
So it is not possible to pass current throughout the circuit or throughout the heater through the or okay.
Okay.
Okay, now they are asking the suggestion that suggests one reason why the circuit is designed so that the heater cannot be switched on when fan motor is off. So the main thing is heater is switched on when the fan motor is off.
Like what should I say? Like the
So
reason why it's not open over.
yes, so they are asking why design circuit like this that heater cannot be switched on when fan. Actually, if you consider the whole circuit, so this is a complete circuit of one single device, right? So the
Okay.
purpose of heater to provide a thermal energy or heat energy, right? And fan motor actually works like a exhaust fan, right? So it just
Yeah.
throw out the additional thermal energy from the circuit. So your circuit will not heat up and it will not melt out or it will not blow out, right?
It's a fan oven also.
Yes. So basically fan is actually connected over here to cool down the system or to maintain the temperature of the device. Otherwise this, if we just turn on this heater directly, so there will be, due to high temperature or due to high thermal energy, it
It
may
might
be
not work.
melt down, or yes, it will not work after that. So state one reason why the circuit is designed. So circuit is designed to,
Cool down.
yes, to cool down the temperature, or we can also control the energy or the temperature of the device, right?
Yes.
There are multiple options to put the answer. So of 1 mark, so you just need to write one main key point in this question.
Okay.
This is our main purpose, right? Because by name of the devices you can easily understand that why we are using fan over there, because with
Yes.
every heating device just like PC, laptops, there is an exhaust fan connected with it. So let's suppose if there is no exhaust fan, there is no sync over the processor, so it will only work for 1 or 2 seconds, then it will automatically switch off because of very high temperature, right?
Yes. Yeah.
Yes, now there is a calculation part. The heater and fan both are switched on. So calculate the current supplied to the oven. Now we need to check out the values again. The question is we need to find out the value of current unknown. Now let's find out the other values given in the question. Uh, Power of heater is given, right? Like P1, uh, and the main source is actually equals to 30, right?
Yes.
So if we just simply add the power, so total power is 3700, right? So the total power is equals to P1 plus P2.
That is 700.
Yes, we need to show the addition 3500 plus 200. So it will be equal to 3700 watt. This is your total power. And the value of voltage is actually equals to volt. Now you just need to find out the value of I. So what is the formula to calculate the value of I?
I equals V over R.
But the value of resistance is not given.
Oh, okay. The I equals V over T.
Okay, so yes, we need to use the basic formula. So I is equals to P over V. So your answer will be equal to
It is 16.08.
16.08.
8.
Okay, so we just round off it to 16 ampere, right?
Yes.
Okay, next part is related to your next chapter. So this part for a time being, this part is also kind of with the second one. Yes. So next part is actually connected with your next chapter. So we will complete this question when we just talk about the concepts of new chapter. Okay. Because you know that in your past paper, like the previous topic, all questions are connected, all concepts are connected. So that's why we are solving those questions which are actually related to our first electricity chapter. Okay, this is also from the next one, thermistor. Okay, we also discuss about right?
Yes.
Because in the topic of non-ohmic conductors, right? So it
Yes.
means that we're able to solve this question also. Let's try to solve this one. A student connects a thermistor in series with a battery. So note down the important components. There is a thermistor, and most important thing, it is connected in series with a battery and an ammeter. He uses the resistance of the thermistor to determine temperature. In space below, draw a circuit diagram showing the thermistor, the battery, and the ammeter. So we need to show all these components in a form of circuit. So how we are going to draw the circuit? Uh, do you know about the symbol of thermistor? How to draw a symbol for thermistor?
Uh,
If you don't know, I will draw it again. You may check from your notes afterward. So the diagram for thermistor will be like
oh,
this.
it's like a, yeah,
Yes. And for battery, you know that we need to draw one large line and
big line and small line.
shorter. Yes. And for ammeter, you just need to write A in the
Yeah.
circle. So that shows you the meter. And all are connected in series. So now circuit is very much simple. You just need to start. Let's suppose we started from a battery
Then the
and we
resistor,
connect a thermistor, right?
and then the
Yes. So question is all, so it is like free
it
3
won't
mark.
matter. It won't matter where you draw this thing, right?
Yes. So if you want, you may write plus minus. Otherwise, it is definitely understood that that large line shows positive and short line shows negative sign. Okay, in the next part, the student places the thermistor in a water bath and various temperatures and records the reading on the ammeter. And the graph shows the current varies with the temperature. We know that the working of thermistor is also linked with the temperature. So student place in water surface and records the values. And this graph shows you the value. First, check out the question, what they are asking, then we come again to the graph. Okay, so one more important thing, that potential difference remains constant. So the potential difference is constant for the thermistor, and the resistance of the thermistor is 240 ohms. This is the value of resistance and this is the value of
Yeah.
temperature. So you need to calculate the value of V. This is the value of V, this is the value of R, this is the value of T. Now one thing is missing, that we need to
The
calculate the
energy.
potential difference. Uh, For potential difference, we know the basic formula for power. We use the formula power dissipation, but let's check what values are actually given in the question. So you can see that with the help of temperature, we can easily find the current value from the graph, right?
Yes.
So the temperature is 20 degree. So let's mark the value 20 degree. So 20
And it's
degrees is
five.
over here, right?
Yeah.
So you need to check out this point,
Five.
that how much current, 0.05. 0.05 ampere is the actual value for our question. So we just write value from the graph. I is equal to 0.05 ampere and R is equals to 40 ohm and T is equals to, okay, so T is not compulsory for our question. So we are not going to write the value.
It's V equals I over R.
T is equals to I R, Ohm's law, right?
Yes, sir.
So
So
just to
12,
again multiply the thing.
12.
Okay. And second thing is the resistance of the thermistor at 40 degrees Celsius. So again, we need to check the graph at 40 degrees Celsius to find out the value of I first. So at 40, this is 40,
0.12.
0.12. So 0.12 value of I for the second one, 0.12 ampere. And one more important thing in the question, that potential difference remains constant, right?
Yes.
So that we need to use the same value that we already
12.
calculated. 12 volt, right?
Yeah.
And the other value is R. We need to calculate the R. So R is unknown. We just use the formula again. R equals to V over
I
I.
V over I, and then 12 divided by 0.02 is 100.
Okay. Now we get value 100 is the symbol SI unit. Okay. Okay. Take the screenshot of this question. So you may solve this question by yourself and send me in the chat. I will check your answer. And from next class, we will start with the new topic and the new chapter, practical electricity. And then we try to end up that chapter in the next week. So we have enough time to solve the questions, because there are many questions. You can see that 151 pages. And we
Yeah.
also need to start electromagnetism, because electricity is a lengthy section. And this is also a very important one. And you can see it is interesting and not very difficult, right?
Yes. Yes.
Because questions are straightforward, because mechanics is slightly difficult as compared to electricity, because mechanics is completely related to our daily life. Okay.